So what we're going to be talking about today are significant figures. We're actually going to do a quick review of sig figs, and then we're going to also talk about the difference between accuracy and precision. So that's going to kind of be our quick little focus here. So before we start anything, we need to make sure that we know the definition of a significant figure. So let's repeat this together. So a significant figure is all the numbers precisely known plus one estimated digit. That's awesome. Okay, so now remember, the rules are pretty simple. If it's a number 1 to 9, then those are always significant. What if it's a trapped zero? Always significant. What if it's a 0 to the right? It needs a decimal in sight. What if it's a 0 to the left? It's never, ever significant. Now, I just want to make sure that I clarify this because I think there are people that were confused about this too. When I say a 0 to the left, I'm talking about to the left of an integer between 1 and 9. Okay? So in other words, if it looks like this, zeros to the left are all of these zeros, okay? All of those zeros. We're not talking about zeros to the left of a decimal, okay? Because there would only be one situation. Those are never significant. You never need that number. And you would never have zeros written on that side anyway. So when we say zeros to the left, we're talking about these zeros to the left of your number 1 to 9. Okay, that's what we're talking about. Zeros to the right, again, we're not talking about zeros to the right of a decimal because people seem to be confused about that. We're talking about zeros after your numbers 1 to 9, at the very end of your number, okay? That's what we're talking about. So we're not talking about to the left and right of a decimal. We're talking about at the beginning or the end of a number is what we're looking at, okay? All right, so let's go over the song real quick. So remember, it goes to cheerleader, okay? So it's, and we're just going to kind of sing it together. So we'll start at oh, I think that I found myself a sig figure. It is always right there when you need it. Oh, I think that I found myself a sig figure. It is always right there when you need. Here we go. 1 to 9 is the model, or a trap zero like a sig fig in a bottle. Yeah, yeah. And zeros to the right need a decimal in sight. Zeros to the left are never ever significant, and they say, do you need me? Do you think I'm bigot? Do I make you feel like cheating? I'm like, no, not really, cause okay, we're good. You guys are awesome. Round of applause for you guys. That's great. Okay, so we know our rules. We've got our rules down. So keep in mind that when you're multiplying and dividing, it's pretty simple. All you're going to do is you're going to count your sig figs. So this one has how many sig figs? 2, and this one has 3. You round it to the one that's less. So what we're going to do is we're going to take our 0.5841 blah, 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 and we're going to round it to 2 sig figs. And the way we do this is you start with the first sig fig from the left. That one doesn't count. So I'm going to start here. I put a dot there, and then an arrow. So it's 2 dots, and the arrow comes off of that second dot, okay? Round up or not? Not. So that means, again, you just cut your number off, and it's going to be 0.58, and then you're done, okay? So multiplying and dividing is always super, super easy. Adding and subtracting is a little bit more challenging, okay? So with adding, and we don't really add or subtract in chemistry. The only thing we really add or subtract is when we're doing our molar masses. That's the adding and subtracting part. So if you always are in the tens place, then what should your answer be in? The tens place. It's going to be over and over again in the tens place. But what if it's not? What we do is we say that your answer cannot be any better than your worst estimated digit. So if you're estimating in the ones place, then that's actually that's worse than estimating in the tens place. So the tens place is actually going to be better than the ones place. And so is the hundreds place is even better than that. So if your instrument only measures to the ones place, and that's where your estimated digit is, then your answer cannot be any better than that. Okay? So what we do is we actually line them up. You line them up by decimal. And then you underline, this is the way that I do it, I underline the estimated digits. So the 5 is estimated here. What about in the 9.1? Which one's estimated? So the 1 is where we're estimating. So which place is bigger, the hundreds or the tens? The hundreds is better. That's a smaller number, right? So which one's bigger is the tens. So this is where we want to stop our answer. So that would be your dot and your arrow. Okay, so that's where you're going to end your answer. 5, round up or not? Up. So the 5 is going to round the 8 up to a 9, and you're done. So now if you did your multiplication rules, it doesn't work. So if we did this as multiplication rules, that would be a 3 and a 2, and we would want 2 sig figs in our answer. So it's different. You can see that it's different. So adding and subtracting has different rules. Let's try just one more together right here. So here, we're estimating in the ones place. Here we're estimating, that's the tenths, that's the hundreds, so what's that? Thousands. So that's a thousands, that's a thousands, and this one is in hundreds. Which one is the biggest or the greatest place? The ones, right there, the 4. So you cannot be any better than this place because you're estimating there. That's where you stop your answer. You look there to round, and so your answer would be 828. Okay? So again, if you use sig figs, you would say 3, 4, 4, 2. You would only want 2 sig figs. That doesn't work. So adding and subtracting is different from multiplying and dividing. And the last thing is accuracy versus precision. So real quick, accuracy is going to be how close to? Actual. So everybody say accuracy, actual. Accuracy, actual. Okay? And so if we're going to look at a bullseye in just a second. Precision, pre is reap. Everybody say pre-reap. Pre-reap. So it's repeatability. Well, if we're looking at a picture like this is only accurate. Why? You're hitting right on the bullseye. It's close to the actual, and the actual spot you want to hit is the bullseye. This is only precise. Why?
It's the same thing.
Yes, it's in the same spot over and over again. You're repeating it. That's repeatability, but it's not hitting the bullseye. This is both accurate and precise because not only did we hit the bullseye, but we hit it
Multiple times.
We repeatedly hit it over and over again. Okay, and that's basically our review of significant figures and